Okay, so the last video was looking at permutations. So this one is how do you calculate the number of combinations? So number 6 is a combination where the order doesn't matter. It says there are 110 people at a meeting. They are shaking hands with everyone else. How many handshakes were there? So it doesn't matter. I could shake hands with another person and then we turn around and shake hands again. No, we already shook hands. So this will be a combination. I'm going to put C for combination. So out of 110 people, how many different combinations can occur? Okay, how many handshakes are there? So first, you want to do like we did with the permutations. You want to figure out there's 110 people and they're shaking me and one other person and then someone else and one other person. So you want to first calculate what the permutation be. 110 times 109. Okay, we got 110 times 109. That's the number of permutations if the order did matter. But since the order doesn't matter, we need to divide that by this way. Since there's two people, we want to go 2 times 1. Okay, there's 2 times 1. So here then, you got to go 110 times 109. That'll give you the permutation. And then to figure out the combination, if the order doesn't matter, it's going to be a lot less. So you got to divide it by, well, here I got 2 times 1, that's going to be 2. Okay, so therefore the answer would be, there will be 5,595 handshakes at that meeting. So this is the number of combinations that will occur. Okay, so here you got to figure out the permutations first, and then if the order doesn't matter, then you have to divide by the number of not the number in the group, but how many position, or in this case 2 combinations. Anyway, here let me show the next one. See if this one makes it a little bit clearer. I'm going to skip number 8 because that one's kind of a rough one. And I'm going to go to number 9. It's another combination. It says here, a team of 17 softball players need to choose 3 players to refill the water cooler. So it doesn't matter what 3. It can be any order. So here I got 17 softball players. And if first I want to figure out the permutation. Okay, I got 17. And I got 3 players to do the refilling. So I got 17 times 16 times 15, and that'll give me the permutation. Okay, how many if the order did matter? But since the order does not matter, I have to divide it then by there are 3 players, so I gotta go 3 players times 2 players times 1 player. Okay, so I got that many players. So this is counting down 3 positions from the total set. And then here at the bottom is counting down from the total positions that you're pulling from the set. And you might want to replay that again, but that's the best way I can describe it. So to find the permutation, you're counting down the number of positions from the total set, 17, 16, 15, and you're multiplying them. And then to find the combination, you're counting down from the number of positions. 3 times 2 times 1. Okay, and then you have to divide that. So here on the calculator you go 17 times 16 times 15 divided by 3 times 2 times 1. So you would that would be 3 times 2, that's 1, that's 6. And this one would be an even bigger number. But on the calculator it will come out to, I worked this one out earlier, it comes out to 680 possible combinations. Okay, So this is the extra step with combinations. If you're doing permutations, the number's greater, then you just do the countdown and multiply them. But if you're doing the combinations, the number's going to be less, so you have to divide by the number of positions and do the countdown, multiply them, and divide them into the top number. And that's where number 8 is kind of harder. It says here, a group of 25 people are going to run a race. The top 8 finisher advance to the finals. So it doesn't matter the order that they finish. You could come in 8th place and you're still going to advance. So out of those 25 people, how many combinations, this is combination because the order doesn't matter, how many combinations can you make out of these 25 people if you're just pulling 8 out of the group? So here, wow, I got 8 out of the 25. So here I got to go 25 to find the permutation first. I got to go 25. I got 8 positions. 25 times 24 times 23 times 22 times 21. 1, 2, 3, 4, 5, 3 more. Times 20 times 18. No, 19 times 18. Holy smokes. Now you can see why I skipped this one to start with. So you got to go, that will give you the permutation, but this is combination. The total doesn't matter. So I got 8 positions. So here, to divide the permutation to find the combinations, you got to go 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So this one I did, of course, earlier on the calculator. So you go 25 times 24 times 23, 22, 21, 20, 19, 80. You multiply those and then divide it by whatever this equals, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And ended up being, wow, it was a big number. It came out to 81,575. Okay, so that's how many combinations out of that group of 25. And you can see here, and that's what they, now you can see like the lottery. If there are 25 numbers in the lottery and you chose only 8 of them, there's over 1 million ways you can do a combination of those numbers. So your chances of winning are 1,081,575 to 1. So the chances are you're not going to win. Okay, so so those are combinations versus the permutations, and then the next video I'll do the last 4. You can try these 4 on your own, see if you can figure them out, and then the next video I'll show you how to do those last 4.